Good evening, AP Calculus students. Hopefully you've had a good weekend. So this video is just to help you out with one part of the three things that are due after this weekend. Remember, you do have a Delta Math that is due tomorrow. So I think the Delta Math should be fairly quick if you were following what was going on in class on Thursday. So we have begun just solving straight up pure integrals, right? So there's two sections to the Delta Math. The first part is just solving for definite integrals, the most basic form, and the second part are properties of definite integrals. You will see two sections to this video that will take you through both. Now, the first part, we are going to solve this definite integral, right? So I'm going to break this into two steps, right? Step one, actually I'm going to zoom in. Step one for this example is we're going to solve for the indefinite integral. For the indefinite integral. Now, if we remember what that is, that's essentially just the reverse of the derivative. Reverse of derivative. Right? Easy enough. And the question I ask myself, I'm going to say method for this specific problem, is I think about the question, this function is the derivative of what? This function is the derivative of what? And in this case, what I mean by this function is the function right here, 8. So I'm going to write, my method is going to be 8 is the derivative of what? Right? 8 is the derivative of what? Well, think about that. So actually say that phrase out in your head. 8 is the derivative of what? And your answer should be that 8 is the derivative of 8x. 8x, right? Hopefully that makes sense, because if I were to take the derivative of 8x, it would be 8. Right? So first, step one, it's going to be 8x. Then I'm going to go on to step 2. Actually, I'm going to label my integral. Usually they label as the capital F of x function. Right. Step 2, I'm going to plug in my numbers. So my actual final integral from 1 to 4 of 8 dx. What that is going to be I'm going to plug in my numbers 4, and then I subtract and I plug in my number 1. Right, so although I did my step 1, I found my indefinite integral. To find my definite integral is just one extra step, and I'm going to plug in say plug in your interval and subtract. So when I plug in 4, capital F of 4, that's going to be 8 times 4. 8 times 4. Minus, when I plug in 1, that's 8 times 1. So that simplifies to 32 minus 8. That's equal to 24. My answer is going to be 24. Answer is 24. All right, let's try another example, right? So I'm going to copy down the steps again, right? So my first step is step 1 right here. Let's put that right there. Then step 2, I will copy that as well. All right, so let's think about step 1 for this problem. Step 1. Again, I'm going to solve for the indefinite integral, which is the reverse of the derivative. Now, this one's a bit tougher, so I could think this same question. In this case, not 8, right? I think, what's the method we think about? 14x plus 8 is the derivative of what? Right, 14x plus 8 is the derivative of what? But if you remember in class, we did say sometimes the questions can be kind of tough, right? I don't have this right off the bat memorized. 14x plus 8 is the derivative of what? I don't know. The 14x is confusing. So we have another method for this to get to the reverse of the derivative. The other method is something called anti-power rule. So I'm going to say anti-power rule. And my anti-power rule is this. If I take the integral of x to the n, it turns out to be x to the n plus 1 divided by n plus 1. And then you usually write plus c for indefinite integrals. Okay, so let's do that. This is 14x to the first power, right? So if I apply anti-power rule, it would then be 14x to the second power, right? Because I'm adding 1. 14x to the second divided by 2, because 1 plus 1. Right, so 14x squared divided by 2. Then I'm going to take the integral of 8, and that one we actually, mentally, we're just going to apply what I know about integrals. The integral of 8 should be 8x, because I'm thinking 8 is the derivative of what? I don't really apply anti-power rule for that. But this is my indefinite integral, right? I can simplify this to be 7x squared plus 8x. And if I ever want to test my integral, if I ever want to know if this is correct, I can do the derivative of this, and you'll see the derivative of that is 14x plus 8. All right, hopefully that makes sense. Cool, so I would say the part that takes more work, because remember, step 2 is literally all about plugging in my numbers and subtracting, plug in my intervals and subtract. So first I'm going to plug in 1 into my function, so f of 1 minus capital F of 0. Right, when I plug in capital F of 1, I would get, I'm going to use brackets to really show I'm plugging 1 into the whole thing. So I'm plugging 1 into here. So it's 7 times 1 squared plus 8 times 1. I plug it in for both of the x's. Right, both of the x's. Cool, so I got that part. Then I'm going to subtract, and then I'm going to plug in 0 and plug it in for both of the x's. So 7 times 0 squared plus 8 times 0. All right, then I simplify this. 7 times 1 squared is going to be 7 plus 8 minus this whole thing simplifies to 0. So it's equal to 15. My final answer is 15. Cool. Here, I'm going to zoom in on this very third problem and just solve it extremely quickly, just to show you how you could solve this quickly without writing every single step. Right, so first thing I will do is solve for the indefinite integral. So that's my anti-power rule. So it's going to be 6x to the 3 divided by 3 minus, remember this is 4x to the first power, so it's 4x squared divided by 2. Right, that's my anti-power rule. Now, if I simplify this, that's 2 x cubed minus 2x squared. And if I were to want to check my answer, remember, this should be the reverse derivative. So if I want to take the derivative of this, derivative of 2x cubed is 6x squared. Derivative of 2x squared is 4x to the first power. So I know I did my integral correctly. All right, now I plug in my numbers, right? So I'm going to plug in 3. It's my first number here. Then I subtract and plug in 2. Cool, when I plug in 3, I'm going to get 2 times 3 cubed minus 2 times 3 squared minus, when I plug in 2, it's going to be 2 times 2 cubed minus 2 times 2 squared. All right, so I plug everything in, and I just solve. So in this first bracket, when I simplify this, obviously you could use a calculator for this. Let me just think about this. I believe that simplifies to 36 minus minus 8. Right, so 36 minus 8, my final answer should be 28. All right, hopefully therefore you see the steps of how to solve the indefinite intervals. All right.
Hello everyone. So AB students, this is my video for today's homework assignment. Now really quickly, today there are a decent amount of questions of today's homework assignment, but each question in of itself should not take that long. As you can see, I have an example question right here, and each of them are honestly, hopefully, relatively quick. So what I'm going to do is go through a few of these and show you all my steps and my thinking and how I apply the properties, and hopefully you can do the same. So my first recommendation is, so I'm going to write step 1, generally. So I recommend, this is usually helpful, recommend that you start from your end goal and work backwards. So what I mean by starting from your end goal is, what am I trying to find? What is the answer? Well, this problem asks me here very clearly, what is the value of my integral from -1 to 10 of f of x dx? My integral from -1 to 10. So what I'm looking for is this, the integral from -1 to 10 of f of x dx. Then I guess step 2, step 2, use the integrals given to you to try to get to your answer. So we're going to use the integrals that are given to me. And what's given to me? And I'm going to use kind of a shorthand writing for this integral. So I'm not going to write the whole f of x dx, but my integrals given to me are 9 to -1 is equal to -1. And my integral from 9 to 10 is equal to 3. Cool. Okay. Well, the first thing I'll notice, personally, that I notice is that my integral goes from 9 to 10. I'm trying to get from -1 to 10. So what I'm really missing is that part from -1 to 9, right? From -1 to 9. I'm missing that part. Well, that's perfect. I could definitely use this integral, except it's flipped around, right? It's from 9 to -1. So in order for me to use this, I'm going to flip this. So my order of integration is going to become the integral from -1 to 9. Integral from -1 to 9, and that's equal to +1. Right? So this right here is my integral, my order of integration property. When I flip these numbers, you see -1 and 9 are flipped. My answer turns from -1 to +1. Cool. So my integral turns positive. Then what I'm simply going to do is add this integral to the integral to my top one from 9 to 10. So again, if you imagine this, my integral goes from -1 to 9, then 9 to 10. That results in what? That results in an entire integral from -1 to 10, which is exactly what I'm looking for, right? So my answer is going to be 1 plus the integral from 9 to 10 is 3. So my overall integral is going to be 4. So let's write that. Excellent. Cool. So let's move onwards, upwards. Is that a phrase that, I don't know. Anyway, let's start again. So, first things first, what is my end goal? Where am I trying to get to? Well, I'm trying to get to the integral, apparently, from 0 to negative 9 of f of x plus 2 dx. Right. Excellent. So this one's actually this one's probably one of the harder ones, just because I see this weird thing that's going on with this integral. So let's use the integrals that are given to us to try to find my answer. So my integral is from 0 to 10 of f of x. So my integrals from 0 to 10 is equal to 7, and my integral from negative 9 to 10 is equal to negative 3. Okay, cool. And one other right off the bat thing I would like to apply to this is my sum and difference property. I'm going to separate this integral. So my integral is actually from 0 to negative 9 of f of x dx plus, so let me write this here, plus my integral from 0 to negative 9 of 2 dx. Excellent. So I think this part, let's first find this integral. So my integral is from 0 to negative 9 of f of x. Okay. Well, notice that my one integral here is from negative 9 to 10. Right? So I'll say this, my integral is from negative 9 to 10. If I go from negative 9 to 10, but then I subtract this integral, so I subtract the part that's from 0 to 10. So negative 9 to 10, and I subtract the part that's from 0 to 10. What am I left with? I want to be left with just the integral from negative 9 to 0, which is basically what I'm looking for. Right? So let's see what this is going to be equal to. The integral from negative 9 to 10 is negative 3, minus the integral from 0 to 10 is 7. So that's going to be equal to the integral from negative 9 to 10, which is negative 10. However, notice the integral I'm trying to find is from 0 to negative 9, right? 0 to negative 9 rather than negative 9 to 0. So they're flipped. So instead of negative 10, it's going to be positive 10 here. Positive 10. Cool, so I found that first integral. Now let's look at the second part. So I'm going to erase this. So my next part is the integral from negative 9 to 0 of 2. So this has kind of the same concept of base times height, right? So base times height, except one thing that's kind of different about this one is that the negative 9 is the higher number, and we always do the upper number minus lower number. So I'll basically show you what I mean. My base is going to be the top number minus lower number, so negative 9 minus 0 times my height, which is 2. So that's equal to negative 18. Right, so still the base height concept, except my base is negative 9 because I go from 0 to negative 9. Right? And when I go from 0 to negative 9, my base is going to be then negative 9. My height is still 2. So it's going to be 10 plus negative 18. So that should be equal to negative 8. Excellent. Cool. Let's keep it moving. One moment. Okay, the next one is the integral from I think this might be my last one actually. So my integral, what I'm looking for is my integral from negative 2 to 6 of f of x dx. That's what I'm looking for, right? And what am I given? Well, I am given my integral from 5 to negative 2 of f of x dx. Or so I'll just not even write that. I'll just say my integral from 5 to negative 2 is equal to 7. And my integral from 5 to 6 is equal to negative 2. Excellent. So basically, if you take a look at this, I have my integral from 5 to 6. What I really want is my integral from negative 2 to 6. Right? So what am I missing? I'm missing the part that's from negative 2 to 5. my integral from -2 to 5. Well, luckily I have something that looks super similar to that, right? I have my integral from 5 to -2. Well, in order to get my integral from instead -2 to 5, all I need to do is flip it, and when I flip it, I'm going to get -7 instead of +7. Excellent. So now I have everything I need, right? So I take my integral from -2 to 5, I add it to my integral from 5 to 6, and that results in my integral from -2 to 6. Hopefully that makes sense. You have -2 to 5, then 5 to 6, so you have the whole thing from -2 to 6. Cool, and we solved this already. You said this integral is -7, plus the integral from 5 to 6 is -2, so that means my answer is -9. Let's do that, -9, submit answer. Excellent. Okay, so hopefully those 3 quick example problems were helpful. The second one especially was actually one of the most difficult ones I've seen on here, so hopefully you don't get any like that. But in general, yes. Hopefully these were helpful. Again, if you have any questions with this, be sure to message me, just because these should be quick. If you're taking more than, I'd say, 2 to 3 minutes per problem, I think there might be some misconceptions that are there. Once you get the hang of it, it should be quick, every problem. Okay, hopefully that's helpful. And yeah, again, message me if you have any questions. Bye, everyone.